Good morning, everybody. I'm going to do another little practice sheet on solving systems algebraically. I feel like yesterday might have been a little bit overwhelming, so I want to do a couple more problems with you guys today. I'm going to show number 1 and number 2. In number 1, I want you to be able to identify that your first equation in this system is linear, and your other one is quadratic. Okay, so when you notice and you're looking at both systems and they are both equal to y, right? If y equals 3x minus 6, and y also is the exact same as x squared minus x minus 6, then that means they're equal to each other. You could set equal to each other, okay, if they're both equal to y. So if I'm going to put the x squared minus x minus 6 equal to 3x minus 6. Okay, and now if you're solving, we're looking at a quadratic, you want to get everything to the left side and set it equal to 0. So I am going to show that I'm going to subtract 3x. Look where else I subtracted. It's like term, and I'm going to add 6. Okay. So when I do that, this is gone and this is gone. They both become 0. I have x squared minus x minus 3x is minus 4x, and negative 6 plus 6 is another 0 equals 0. So most of you will look and struggle with this. It is not the difference of two perfect squares. And it's not a trinomial. It's missing that third term. If you look, what's the first thing you should always look for is a GCF, and it has a GCF. The GCF is an x. They both have an x in common. So divide each term by x, and you get x minus 4. Okay, do you remember what you do from here? Set up your t. Take each piece and set it equal to 0. The left side is done already. The right side, when you add 4, technically to both sides, x is positive 4. So you have two parts. This means that this parabola and this line is going to hit in two spots. You know that because there are two x values, which means if you opened up two sets of parentheses, one x value is at 0, the other x value is at 4. Now, what do we need to do to find the y value? Take one of the two equations. It doesn't matter which, but the linear one is easier. If I take y equals 3x minus 6, and I plug in 0 for x, I would get y equals 0 minus 6, which means when x is 0, y is negative 6. Okay, we're going to do the same thing for when x is 4. Take that same linear equation and now plug in 4 for x. So 3 times 4 minus 6, we're going to get 12 minus 6, which is 6. So that means 4, 6 is your other point of intersection. So now I'm going to prove it to you. I'm going to go into the calculator and show you this system is how you could easily check your answer. So we have 3x minus 6. I'm going to go into GeoGebra. I'm going to clear everything out, and I'm going to do 3x minus 6 was the first equation. Enter, and x squared minus x minus 6 was my other equation. I'm going to make this one blue. And what am I going to do? I'm looking for my points of intersection. So there's one of them. I'm going to touch where I see them intersecting. Not my extremum, my point of intersection, 0, negative 6. So just go back and check. There it is. One of my points of intersection, one of my solutions is 0, negative 6. What's my other one? If I scrunch down right there, intersect at 4, 6. And you see that as well right here. Okay, so that's just, again, another little clarification on that's a quadratic linear system. Okay, so now let's take it up a notch, a little bit more difficult. Couple of things that are a little bit more difficult about number 2. In number 2, we're no longer talking about a quadratic linear system. The first piece of this system is linear. Okay, but why is it a little bit more difficult? The x plus y equals 5. This linear system is not solved for x or y. Okay, that's one thing. The second thing is this system in number 2, the second equation, x is squared and y is squared. This is a circle. So in order to plug in and use substitution, you need to take your linear equation, x plus y equals 5, and either solve for x or y. You could pick whichever one you want. So I don't know what everybody prefers, but I'm going to just solve for y. So if I want to solve for y, the first thing I would do is subtract x from both sides, right? You're very used to doing that by putting the equation into y equals form. So if y equals, you can't combine those. They're not like terms. You would have negative x plus 5. So here's your new linear equation. So now watch. If y equals this, y is equal to negative x plus 5. Wherever I see that y, I'm going to put in negative x plus 5. So I'm going to use a new color. I'm going to go purple. And if I rewrite this equation, x plus 3 squared plus, now look what's going to happen. Instead of y, I'm going to put in negative x plus 5. And then don't forget your minus 3 squared equals 53. So I took what y equaled, negative x plus 5, and I put it in for the y value. What did that do for us? It had an equation with x and y and made it only x's. So now let's just simplify where we can. If you notice here, I have two numbers. I'm going to combine them. I have x plus 3 squared, and then I have negative x plus 2 squared. Okay? This x plus 3 squared and negative x plus 2 squared, sorry, that's my dryer. God, that's so loud. You could either do double distribute or the box method. So I'm going to just show this means x plus 3 times x plus 3, and this means negative x plus 2 times negative x plus 2. Okay, so if I double, I get x squared. I get a 3x and another 3x and a 9. 3 times 3 is 9. If I do it again here, double distribute, I get positive x squared, negative 2x, another negative 2x, and positive 4. Okay, so we have a lot of like terms. I have an x squared with an x squared. That gives me my 2x squared. We have, I should pick a new color. I have 3x and 3x, which is 6x. But minus 2x is 4x. And minus another 2x is positive 2x. And then I have, new color, more like terms. 9 and 4, which gives me 13. But it equals 53. Do we want it to equal 53? We're looking at a quadratic. We want it to equal 0. So let's move that 53 over. And now I have 2x squared plus 2x plus, nope, just kidding, minus 40 equals 0. Now, being that we see a GCF and we have an equation because it's an equal sign, I am allowed to just divide every single term by that GCF. So now we have x squared plus x minus 20 equals 0. Okay, so I'm going to bring that up here. X squared plus x minus 20 is a basic trinomial. What two numbers multiply to negative 20 and add to 1? Well, that's easy. Your two numbers have to be consecutive. 5 and negative 4. plus 5 minus 4. So when I set up my t, x plus 5 and x minus 4 equals 0, x equals negative 5, and x equals positive 4. So just take note, this is a circle linear system. Think about a circle, think about a line. This must intersect in two places. How do I know? I have two x values. Now you can't stop there. It just means that there are two solutions, negative 5 something and 4 something. Those are your x values. If you had chosen the beginning to solve for x equals, you would have gotten two y values and you would have just put them in the back of the parentheses. So now use your linear equation. Let's use x plus y equals 5 to plug in for x. Negative 5 plus y equals 5. If here we add 5, we get y equals 10. So that means when x is negative 5, y is 10. Okay, let's do that same thing. X plus y equals 5, and now plug in 4 plus y equals 5, making y equal 1. So let's do the double check. Let's put both of these into the calculator and prove that negative 5, 10, and 4, 1 are our solutions. Okay, so here we go. We got x plus y equals 5. I'm going to go into GeoGebra to prove it to you. X plus y equals 5. So there's my linear. Okay, my circle is x plus 3 squared, y minus 3 squared. So this is going to be x plus 3 squared plus y minus 3 squared equals 53. And there's my circle. Okay, look at how perfect. Touch on one of your points of intersection, 4, 1. Touch on the other one, negative 5, 10, and there they are, 4, 1 and negative 5, 10. Again, I can't stress this enough. These are what we call the solutions. They must be stated. Again, even up here, make sure you write that those are the solutions. Okay? I am going to stop there. I'm going to make you guys try those next 3. I'm going to post your answer key, but I want you to try those next 3 on your own, okay? Please contact me if you want a little extra help. Okay, miss you guys.